Okay, so this video is on the making of the X-axis plates. So I'm calling this the left axis plate, and this one here is the right axis plate. They're both made out of 1/4 inch aluminum. This one is 5 inches long. It's 3.5 inches wide. The stock that I bought is 3.5 inches wide. So I just have to cut this one 5 inches long and this one 4.5 inches long. Now, I'm including these on the links. The easiest way to do this is, you see there's a lot of different holes on here. So there's no point in measuring from each hole to each hole and so forth. But I do have the dimensions of what the holes should be, how you should drill them. The easiest way to do this is to cut this, print it, cut it out, and tape it over your stock. So what I'm going to do next, I'm going to cut them out, and then I'm going to show you how I place them on. Now you may notice that the dimensions along the sides are hand done because, as I mentioned, these get cut out, so there was no point in printing them on there. Okay, so as you can see, I have cut out my left one. This is where the stepper motor goes. And my right one. These here are for your bearing blocks. These here are for your support bracket for the rail that goes across. And this will become more clear once it gets assembled. These here are for the kickback nut that brings it up and down. And there's a little bracket that goes on the other side that it goes attached to. So, of course, I've already cut these out. So this is the left side. What you would have done is, you cut this to 5 inches long. You would line up the edges and you will put tape to hold it in place. Then you would take your punch, as I showed on the other video, that golden thing, and you would punch at the center of each hole, so forth, and then you would drill them according to the size. This is 5/32, all of them, and this is 5/32 on this plate, 5/32 on this plate. These are from M5 screws because I'm actually tapping these. These are the only ones that get tapped on these brackets. The rest go straight through and we will not tap those. Now you don't need to tap these. You can actually use a bolt and nut on the other side. Then just use the drill bit that matches your bolt. That's really it. This, I'm doing it at 5/32 because there's going to be a nut that goes through there that's going to hold the pulley that holds the belt going across, that goes on the sprocket here, and that will become clearer once it gets done. Once you mark these and you drill your holes, you can see here 5/32, 1/8 of an inch. This is a pretty big one, 14 and 16ths. On this one, I actually used a big stepper bit that I had. So I made my mark. I made one initial hole with a bigger drill bit. Then I used my stepper bit to go through. The one that I happened to have, actually the biggest size was 14/16, so it fit perfectly. If you don't have that type of drill bit, your other option is to make a bunch of marks around with the punch and drill tiny holes until you're able to cut it out somehow and then file the edge smooth. This you have to get as best as possible because, as you notice, most stepper motors have that little lip that raises up, and that's what goes in here. Once you do that, you should end up with this. You might notice here that I may have over cut it at one end. That's fine because everything lines up. This one here is my left side, as you can see, which that's the intent. These are countersink holes because of the way that I'm designing this. You may or may not want to do that. I'm using a 3/8 metal countersink bit to countersink them because the screws that I'm using, the M4 10mm, are just long enough to give me about 2/16 on the end once I do the countersink, and that was by design. If you don't want to do the countersink, you need to buy longer screws. This two here will be countersink with a 1/4 inch bit because you'll notice that these brackets go over, and I guess I might as well just show you the brackets. I'm sure you're familiar with these. These go here and here for the rail that goes across. These of course go more apart. And as you can see, this good touch. That's why I'm countersinking that one. Depending on how you design yours or how you drill yours, you may or may not need that. If you're following my design, then you'll probably end up needing to countersink these two holes. So these are going to be countersink. These are going to be countersink. These, based on the screws that I have, I don't need to countersink them. And this doesn't need to be countersinked. So, again, this one would have gone over here. And then I would have just marked it, as I mentioned, and I would have drilled it. As of the making of this video, the one that I have yet to cut or drill is the center plate, which is this guy. It's missing some holes because I'm still working on my design on this one, but by the time this video goes out, this will be ready and you will see how that goes. Just want to make one quick note about this hole. Technically, you may not need to do that, at least not this big. You can make it big enough to fit the shaft of your stepper motor. You would just need longer screws to go to the other side. And you just gotta make sure most steppers use M3 screws, so you just gotta make sure that they're long enough to tie in your motor properly, assuming you don't do this. Even though I'm doing this, I still have to use the proper length screws. Another note, I'm making these out of aluminum because, like I said, part of my intent is to try to convert this as well for PCB milling to create PCB boards. So I want it to be pretty strong. You know, I don't want it to flex. But for 3D printing only, I believe you could actually use 1/4 inch plastic plates for this, which are easier to drill and to cut and so forth. I'm not sure how well the 1/4 inch would work for the plexiglass, if that's what you use. I don't know how much it will warp, you know, as it moves up and down and so forth, and with heat. You know, I'm really unfamiliar with that. If you use plexiglass, just test it out to make sure how much it actually flexes. Just in case you don't want to go through all the trouble of doing this and then it's flexing a lot. You might want to use 1/2 inch plexiglass if it's not too inexpensive. I'm not really sure. Or you could use 2 pieces of 1/4 inch plexiglass, glue them somehow together to make a thicker piece. Again, that's just a thought. I'm not sure how you're looking to do this. I found this pretty inexpensive, at least in my area, in the East Coast or Northeast. I'm near the New York area. I actually got my pieces of material in Connecticut. So, good luck.